Hi everyone, my name is Alima and today we'll talk about the Falling Slinky. We'll talk about the fundamental principles used in this experiment, the data collection and analysis, the computational model, the result, and the conclusion. So the purpose of this lab is to analyze the motion of the slinky being dropped from rest by creating a computational model and compare it to the observed motion. The results show that the predicted and observed motion were very similar. However, because of the motion happening so fast, it was hard analyzing it. In this experiment, we used Newton's second law to calculate the velocity and the position of the slinky, the bottom of the slinky. We used the net force, we used the drag force, as well as the gravity. So through tracker, we assumed that the mass was 0.2 kilograms. We extracted the initial position of the bottom of the slinky and the initial velocity. Here is the motion of the slinky through tracker. We inserted the initial condition into the code, as well as Newton's second law to calculate the slinky velocity and the slinky position. Here is the simulation through glow script and the graph of the bottom of the slinky falling. So for the result, we compared both um, motion, the predicted and the observed one. As we can see, the observed motion present a lot of discrepancies because it was difficult to capture the real motion that was happening. However, if we look at the overall shape of the graphs, the predicted motion is very similar to the observed one because at the beginning of the motion, the bottom of the slinky is stationary and then start falling with the rest of the slinky. So what is happening to the slinky? So when the top of the slinky is let off, it experiences the tension of the rest of the slinky that creates an equilibrium with the gravity pulling down. And when the slinky is fully compressed, then the whole slinky falls with the acceleration due to gravity. Conclusion. So in conclusion, the real motion of the slinky is more complex than what we saw. This experiment needs to be improved and, for example, find a way to insert the tension and using the center of mass of the slinky. And the motion was very hard to capture through tracker because the motion was happening very fast. This is the end of the presentation. Thank you.